So today we'll discuss about die casting process. The lessons we can divide in three parts. In part 1 we'll discuss about the die casting process. In part 2 how a machine looks like, different parts of the machines, and in part 3 description of the peripheries like vacuum, thermal devices, streaming machines, robots, etc. What is die casting? This is a manufacturing process where solid metals are melted and heated to desired temperature, after which it is poured or forced under high pressure into a cavity or mold with proper shape. The melting and heating process may require different furnace heating temperatures. Moreover, different chemical substances may be added to modify the chemical composition of the metal. It is this mold that contains the desired shape and size. Die casting is one of the largest casting methods that is used to manufacture consumer, commercial and industrial products like automobiles, car parts, toys, hydraulic parts, gears, etc. You can see during the old days how we used to use molten metal to pour into the desired shapes and then get the desired component. We can name it like low pressure die casting also. But modern days we used the high pressure die casting, where molten metal here in the pressure chamber are being pressed by an injection cylinder or a plunger into the cavity where we have the required shape of the component. This is how a modern die casting machine looks like. This is a Buehler Karat machine. It consists of closing unit, injection unit, the pump or drive unit, which we'll describe on the later on videos. The die casting mold is an important tool in the metal die casting industries. The mold have channels which the molten metal flows to form the desired shape and design. The design of the mold will depend on the desired shape of the final product. These molds in maximum times are being supplied by the customer himself, or we can buy also. We can see the mold, two parts of a mold of the die, the fixed half and the movable half. In the die casting machine, metal is melted on or around 700 degrees Celsius in a melting furnace, then carried over to the holding and dosing furnace of the machine, and then injected onto the mold cavity under high pressure. Common metals used in die casting include aluminium, zinc, magnesium, and copper alloys. We require some metal properties because not all metals or alloys can be die cast. This is due to the varying chemical and physical properties. Heating a metal to desired melting temperature also requires, and after the pressure maybe still the metal remains its properties. We can see a melting furnace where the alloys are being melted on around 700 degrees Celsius and then carried over by an equipment to the holding and dosing furnace, where we can hold the molten metal, and then with the pressure of the injection cylinder or plunger, it is being pressed inside the die where we get the required shape of the component. Because this is a continuous cycle, the dies themselves has to be cooled down. We have to maintain required temperature, otherwise we won't get the precise component. Once the molten metal is injected into the mold, it quickly cools and solidifies inside the cavity. The cooling time can vary depending on the material and the complexity of the part. Some liquid releasing agents are being used for cooling purpose as well as so the metal parts don't remain attached to the die cavity. The injection cylinder, the plunger tip also has to be cooled. Now we can see a cooling device. After the metal has solidified and the part has taken the shape, the die is opened and the finished part is ejected from the mold. Sometimes ejector pins or some mechanisms are used to aid in this process. But nowadays mostly we use the robots for the ejection of the metal parts and transfer to the component to the trimming press. We can see a components which after being ejected, this is actually the part we require, but we have also some overflow parts which will be trimmed in the trimming press. The cast part have some excess material which I have already explained to you are trimmed up by a press machine. It is necessary also some finishing operations such as deburring, means removal of sharp edges or fins by manual, mechanical, chemical or electrical discharge methods according to the customer requirements. So we can see a trimming machine here. It uses high pressure, so the other overflow parts may be cut out and we have the final part. We can see before and after the trimmed. After the components has been trimmed, some operator collects the components, cleans. It has to be sent to the surface finishing, maybe some mechanical works like threading, making some holes, punching, and at the last stage the components are being washed, cleaned with proper way, and then being packed for the customers.